Hello, everyone. Welcome back to Cyber in Practice, episode 14. Today, we're focusing on data tokenization, a security technique used to protect sensitive information by replacing real values with secure tokens. We'll look at why organizations use tokenization, how it reduces exposures, then walk through a live demonstration using sample customer data. What is tokenization? Tokenization replaces sensitive data with unique, non sensitive tokens. The original values are stored separately in secure token vaults. This allows organizations to keep business processes working while reducing how often real customer or financial data is exposed. To understand why organizations use tokenization, let's look at risks associated with exposing sensitive information. Sensitive customer and financial data is high value targets for attackers. If exposed, it can lead to fraud, privacy violation, and compliance issues. Tokenization lowers the risk by limiting where sensitive data exists, replacing it with values that have no meaning by themselves. So, how do organizations reduce exposure while still maintaining functionality? That's where tokenization controls come in. Tokenization depends on several controls working together. The token vault protects the original data. Token management controls how often tokens are created and maintained, and access controls limit who can retrieve sensitive values. Together, these controls support privacy, compliance, and defense in depth. Let's take a look at the technical concepts behind these controls. In this demonstration, we'll work with the original customer data, generated tokens, tokenized output, and token vaults. These pieces show how organizations can protect sensitive information while still allowing systems to use data safely. Now let's see how these concepts come together in today's demonstration. Today, we'll review sensitive customer data, execute a prepared tokenization process, view a tokenized output, review the token vault, and compare the protected data to the original file. The goal is to show how tokenization reduces exposure without disrupting operations. Rather than simply discussing tokenization, we're going to watch the process happen step by step. Now let's move from the concept into hands-on demonstration. We'll use a Kali Linux environment and a prepared Python tokenization process to show how sensitive customer information can be replaced with a secure token while preserving the ability to reference the original values when authorized. Let's move into the demonstration and see how these concepts work in action. We'll begin by navigating into the demo directory where the customer data file and prepared tokenization process are stored. First, let's review the original customer data. Here we can see sensitive information such as customer name, email address, credit card number, and account number. This is the kind of information organizations must protect because exposure could lead to financial fraud, privacy concerns, regulatory issues, and loss of customer trust. At this point, the data is still readable and fully exposed to anyone who has access to the file. Before this demonstration, I prepared a Python script to automate the tokenization process. I chose Python because it allows organizations to protect information consistently and efficiently at a scale. Rather than manually replacing sensitive values, automation makes the process repeatable, accurate, and practical across larger datasets. The prepared script reads the customer data, generates unique tokens, creates a protected version of the file, and stores the original file mapping separately inside the token vault. Now I'll execute the tokenization process. The script is replacing sensitive values with tokens and generated two outputs, a tokenized data file and a token vault. This separation is one of the key security benefits. The operational data no longer needs to expose the real sensitive values, while the original information is maintained separately for authorized users. Now let's review the tokenized data. Notice that the original customer information is no longer visible. The name, the email, credit card number, and account number have been replaced with token values. This means the file can still support business processes, but the sensitive data itself is no longer directly exposed. If this file were accessed without authorization, the token alone will provide little value to the attacker. Now let's review the token vault. The token vault stores the relationship between each token and original value. In a real enterprise environment, this vault would be one of the most protected parts of the system. It would typically be secured with encryption, strict access controls, monitoring, auditing, and limited administrative access. This is what allows authorized systems to retrieve original values when necessary, while keeping most users and applications working with tokens. Let's compare what we just saw. The original file contained readable customer information. The token file replaced that information with non-sensitive tokens. The token vault maintained the secure mapping back to the original values. That demonstrates the purpose of tokenization: reduce exposure, protect sensitive information, and still allow organizations to operate. Now that we completed the demonstration, let's review the workflow one final time. We started with sensitive customer information and identified that data required protection. Next, we applied tokenization to replace those sensitive values with unique tokens. We then separated the protected data from the original values by storing mapping in a token vault. Finally, we validated the results to confirm that the data remained usable while significantly reducing exposure. With that in mind, let's wrap up the key takeaways. Let's close with the key takeaways. Tokenization protects sensitive information by replacing original values with non sensitive tokens. It reduces exposure of customer and financial data, supports privacy and compliance requirements, and helps limit the impact of potential data breach. The token vault is central to the process because it securely maintains the connection between tokens and original values. When combined with encryption, access controls, monitoring, and strong governance, tokenization becomes part of a broader defense and data strategy. The main point is this: protecting data is not only about locking it away, it's about reducing unnecessary exposure while still allowing the business to function securely.
Thank you for watching Cyber in Practice. If you enjoyed this demonstration, stay tuned for future Cyber in Practice episodes.